Irena is a staff applied scientist at PagerDuty, specializing in data mining, machine learning, and information retrieval. In her current role, she plays a significant role in developing the PagerDuty Copilot Assistant, leveraging generative AI to streamline PagerDuty operational clouds. I'll let them tell them more about themselves. Please give a warm hand in welcoming them both.
Hello, everyone. So I'm Irena, and with me today is Suchita, a senior machine learning engineer from PagerDuty. And in this talk, we will share with you our experience and lessons learned from developing GenAI features to production really fast. So let's start with some context. As you all know, at the end of 2022, OpenAI released ChatGPT. There was a crazy adoption. And because people were amazed by its capabilities. They had around 100 million users in 2 months. It pushed a lot of businesses and companies integrate LLMs into their products, and it pushed us at PagerDuty to think about which LLM use cases we should add to our product as well. Our challenge was develop and deploy GenAI feature into production in 2 months. Our motto was think days, not weeks. So, spoiler, we succeeded. We developed and deployed GenAI features into production in 2 months. But before I start, let me briefly tell you what PagerDuty is, what we are doing in PagerDuty, just in case you didn't use our product yet. PagerDuty is a SaaS platform that helps developers, DevOps, IT operators, and business leaders to prevent and resolve incidents that could impact businesses and customer experience. We offer proactive event management across IT environments with features such as native integrations, on-call schedules, escalations, noise reduction, analytics, and we are ensuring real-time data delivered to the right people. Now, let's review the GenAI features we released last year for early access before we start talking about the challenges and the solutions. So the first GenAI feature we released for early access last summer was AI-generated runbooks. Runbook jobs are part of product that allows our responders to run automated scripts to resolve the incidents. To define and write those scripts can be complicated. And this feature allows you in a natural language to describe the job you want, and it will generate the script, because there are a lot of those scripts in the internet for runbooks. In September last year, we released 2 additional features to enhance existing capabilities. The first one was status updates, which is an important step in incident workflow management flow to keep stakeholders up to date. But writing those updates can take significant time from the responder. Instead of resolving the incident, trying to create the status update and send it to stakeholders. And this feature provides a draft and saves a lot of time for actually working on this update. And another feature, the second feature we enhanced, was the postmortem. Postmortems are reports that you create after the incident, and it's very important for your learning, but it's also very time-consuming to create, and this is why a lot of our customers or not always do that for all their incidents. So allowing to generate this postmortem report fast using all the information we have will actually help our responders to create that for most of their incidents, because they don't need to start from scratch. Later last year, we released our GenAI Assistant. It's a chatbot accessible via Slack that answers any questions related to an incident. It supports multiple capabilities from the PagerDuty Operation Cloud. And last, earlier this year, we released AI Automation Digest. So those runbook jobs I mentioned before, when you run those scripts, they create logs. And logs for runbook jobs can be run on different nodes and can be very complex for a human to read when they're stressed with an incident. It can be multiple jobs that we're running, so you need to review a lot of logs. And sometimes the responder is not the one who wrote the script, so they are not sure they have all the information what the script was doing. So these features summarize what happened based on those logs, but also provide next actionable steps of what we suggest to do to resolve the incident. And all those features are available in early access for you to try. And this summer, most of them will GA and be available for all our customers. Suchita and I will be glad to provide more details and answer any questions about the PagerDuty GenAI features after the talk. But now, let's review the key challenges we faced and how we overcome them. So let's start with identifying what are the challenges when you need to run fast, develop something with a new technology was one of them, evolving technology, limited planning, too many stakeholders, concurrent work streams for some companies as ours, and performance evaluation. So let's start with the new technology. We were developing features using LLM models, and we faced extensive learning curve and rapidly changing landscape. We were learning about new models, about new libraries, new LLM providers, while simultaneously developing the production features. How do you choose the best LLM for your use case when a new model probably be released next week? I recently read a phrase that resonates well with our experience. As it often goes, we are investing as revolution is happening. With the new cutting-edge research released daily, it can sometimes feel like ground is shifting beneath our feet. That was exactly the feeling we had last summer. So the decision to develop a central LLM API service, which is used by all our GenAI features in production, enabled easy incorporate of the latest LLM models into our features. And Suchita will talk more in detail about this service that we developed. It's one of our main ways to successfully release features so fast. Next, limited planning, next challenge. When you move fast, you don't have much time for planning. It's leading to evolving requirements, evolving requests, and difficulty balancing priorities. But without a concrete plan, alignment across multiple teams becomes hard to achieve. Even in rapid development, defining minimum required documentation, for example, a design document, is crucial. Also, when you have 10 great ideas to use LLMs, what process you follow to identify, prioritize, and choose the best ideas? Which teams should be involved in each step in the process? It's another question your organization has to answer. Next challenge, going back to the example of having multiple ideas when using LLMs, prioritizing and choosing the best become one important aspect, but also determining the right stakeholders to involve effectively and coordinate across teams. However, when you manage too many stakeholders, it can lead to too many meetings to update everyone with what is happening, what you did last week, and documenting every step can create too much work on documenting and meeting versus actually distracting from actual development effort. This is why well-defined process and role definition for everyone involved can really help avoiding spending too much time on documenting and meetings, which can slow your progress. The other challenge we identified, and it's relevant in our example because we had multiple GenAI features developed at the same time, maybe not for all organizations, but when you release multiple features simultaneously, you can duplicate some of the code or some of the skill set can happen. Each team member might tackle same problems independently, leading to inefficiencies in learning and development. So better alignment and coordinations are essential to avoid such duplications. The challenge also led to our decision to have this centralized LLM API service that I mentioned earlier. And last challenge that I guess we all still facing is how we evaluate well our features that use LLMs. In evaluation, we are evaluating the performance and how we ensure consistent results both offline and online. So dealing with varying outputs and establishing those reliable benchmarks are essential tasks. As new models and technologies emerge, evaluating their performance as well as potential risks become increasingly complex, and this requires ongoing refinement of your evaluation techniques. So now, when we shared all those challenges, let's solve them, or at least most of them. At least this is how, those are the strategies and solutions that worked for us in PagerDuty. So we will start by reviewing the role definition and the process we use for LLM intake to production. Then Suchita will delve into the centralized LLM API service. And finally, we will review the performance evaluation and risk management techniques and plans we use. To successfully roll out GenAI features, we had multiple roles, different teams collaborating, each with their new unique skill set and expertise. Those roles include applied scientists, ML engineers, product development, product managers, engineers from the feature teams. To efficiently and effectively use everyone's skill set, we defined a process for when a new LLM use case idea evolves, detailing each step and which teams should be involved. So let's review the process that worked for us and enabled us to release those features fast. So let's say a new potential use case for LLM comes up from a product manager or product development team. The first step we do is to perform feasibility evaluation. Early in the process, it is important to involve an applied scientist who can evaluate whether the use case can be solved by LLM or suggest an alternative solution, maybe a different ML model or data science technique better fits the use case they had in mind. What we experienced last year, everyone thinks that everything can be solved with LLM. Let's use LLM for everything. Yes, it's a very powerful tool, but it doesn't solve every problem in the world. And you need also, if there is simpler model, simple techniques, why would you use such a heavy and expensive tool? So we will work with the teams to define the data requirements, the model, and the testing plan. It's also crucial to define success criteria for the feature at this stage. I think it's not only with LLMs, with any feature you define, work on. So if we decide that this is a feasible use case and prioritize it, the next step is to write a design document to ensure alignment and review the new use case with security team. You don't want to get to the stage of before releasing to production, security just blocks you and no, it's not possible. You need to make sure that that's a use case that security is aware of, and if they have any additional requirements to add or something that can block your use case, early in the process to know about that will be very helpful. Then we will involve the machine learning engineering team to add a new endpoint to the LLM API service for the new use case. In some cases, the use case may require additional enhancement to the service, such as to support multiple concurrent calls to the LLM or some data pre-processing and additional more complex use cases. At this stage, the applied scientist will develop the logic to the endpoint, and the product development engineer will work with building the user-facing feature, fetching the required data, and integrating with a new endpoint of the LLM API service. We will work in iterations, starting with the simplest approach first. After each performance evaluation stage, we iterate until we meet the success criteria defined earlier in the process. Once we pass the performance evaluation, finally all the teams come together and deploy the new feature into production. Of course, it doesn't end here. We will continue monitoring and gathering user feedback for future improvements. We will keep reshaping. We are still reshaping the process as we learn, but having it in place is an important solution to overcome some of the challenges I shared before. And now I will hand it over to Suchita to talk about the LLM API service.
Thank you, Irena, and hello, everyone. So now I'm going to talk about the service that our team has built to manage LLM access and to provide LLM functionalities to other teams at PagerDuty. Before I talk about the requirements that led our team to create a new service like this, I just wanted to tell you that the focus of many of these requirements was ethical and efficient use of LLMs at PagerDuty. Now coming to the requirements, the first requirement was to enable single point of access to the LLMs. through a service, which could be managed by a single team with data science and machine learning engineering skill set. The main idea here was to abstract away any LLM-related complexities such as prompt design, LLM selection, hyperparameter tuning from other teams who might not have the same expertise in their team. Also, another idea here was to have a central dedicated team that could focus on this new area and build standards and best practices around LLM access, security, monitoring, etc. So that other teams in the company do not have to work on the same LLM related problems which might have been solved by another team at PagerDuty. The second requirement was to enable easy integration of LLM functionalities with the product by providing API endpoints. The idea here was to reduce overhead on product teams so that they could save time and focus on building GenAI capabilities rather than figuring out how to access LLMs and deal with complexities that arise with using LLMs. The third requirement was to make the service very flexible and reliable. Flexible so that the product teams can easily switch between different LLM providers and models based on their requirements. And also we wanted to make it easy to support any new LLM use case in future through the service with minimal effort. For reliability, we wanted to implement few failover mechanisms in the service. For example, what if the primary LLM provider is down? In that case, the service should be able to fall back to an alternative provider to maintain the availability of the service. The fourth requirement was to work with security and legal team to ensure security and legal compliance for the service. Initially, we had identified few but very prominent and high-risk security threats for the service by working with security and legal team, which we needed to address while building the service. Some of them were unauthorized use that could lead to attack or abuse of the service by malicious actors. Then using prompt ejection, hackers can disguise something malicious, can disguise malicious content as legitimate prompts and manipulate LLMs into doing something malicious like leaking sensitive data, spreading misinformation, or something worse. That's why we needed to have few mandatory security controls in place, such as customer authentication, good prompt design strategy to name a few. Fifth requirement was to have continuous monitoring in place for the service. This was needed not only to monitor the service health and performance, but was also needed since this was a new technology and we wanted to have more visibility into the service, into our production. So we needed to log some information on the LLM calls for monitoring. What and how we can log about the LLM calls is somewhat dependent on the third-party providers. Hence, we needed to clearly define what, how, where we are logging, and who has access to what, which is also needed for security compliance. Now let's take a look at the high-level design of our solution that we have implemented at PagerDuty for managing LLM access. As you can see from this diagram, that there are multiple endpoints that cater to the requirements of different GenAI features at PagerDuty. When an API call is made to our service by a GenAI feature, the service first authenticates the customer to make sure, the account, to make sure that the account for which the API call has been made is authorized for GenAI access before forwarding the API call to the LLM manager. The LLM manager acts as the engine in a service which is responsible for building prompts, making calls to LLM providers based on inputs provided in API call, and is also responsible logging for monitoring purpose. Our service runs on Kubernetes, which makes it very robust and scalable. It also helps us to keep adding new endpoints very fast in production, since we do not have to worry about scalability. And we are using microservice architecture. The advantage of using microservice architecture is that the choice of LLM provider and models can easily be decoupled from the service itself, so that the product team can easily switch between providers and models by just passing a prompt version in the API call. Now let's take a look at the goals that we have been able to achieve by building a service for managing LLM access. First, we have been able to standardize LLM access and practices for different GenAI features across a company. And also we are doing the same for different LLM providers that we support. Then we have been able to centralize the verification and monitoring of LLM usage across a company so that the most experienced and skilled team has oversight of which team is using LLMs at company, what is being run in the service. And accordingly, we also have centralized security controls in place for LLMs, which is applicable for all our API endpoints in the service. By standardizing and centralizing all this, we have been able to remove work redundancy and improve team efficiency, which is very important in order to move fast. Then second, we have been able to abstract away LLM-related details from the users, such as prompts, LLM providers, models, by just providing version prompts that contains all LLM-related configs for an API endpoint. We are able to support multiple LLM providers, some of them being OpenAI, Azure OpenAI, AWS Bedrock. And we are also capable of supporting others in future, such as self-hosted models, other enterprise APIs, etc. We have been able to take care of security and legal compliance by having few conservative yet effective security controls in place. To name a few, we have account authentication, we have throttling in place to limit the number of requests for an account in a minute to prevent bad actors from abusing our service. By having the security controls in place, we have only won half the battle, since security is an ongoing process. Hence, we continuously need to assess our security situation and identify new and emerging risks related to LLM, such as LLM bias, hallucination, etc. And accordingly, we need to keep updating our security measures by working with security and legal team. But good thing here is that it is all centralized at PagerDuty. Hence, we can easily apply the security changes across all our endpoints. Today, we have an extensive monitoring strategy in place for the service. We send LLM call metrics to Datadog, such as status, count of tokens, latency, for monitoring health and performance. Additionally, we also collect and log few more LLM call details to Sumo Logic and S3, which can be used for detecting issue, debugging, and for doing some more analysis. We also have few access controls in place to make sure that only the required people have access to the logs. Overall, whatever we have in our service works well for now, but in future, we might want to integrate more other third-party services into our service, depending on specific needs. For example, third-party service for advanced LLM monitoring, or another LLM provider, or something else. Because of the centralized and flexible design of a solution, such integration becomes easy and can be applied across all the Gen AI features in a company with minimal effort. With this, I will hand it back to Irena, who is going to talk about performance evaluation and risk management next. Thank you.
Thank you, Suchita. So let's talk about performance evaluation. I think I mentioned it is one of the challenges when working with GenAI features. So first, we conducted manual testing for every feature we released. For more complex use cases, during the feasibility research, we use internal application to test the performance. In PagerDuty for internal testing of data science models, we use a Streamlit app. Additionally, we use PagerDuty as customer zero, encouraging all teams to use and provide feedback on the features before we release them to our customers. To scale up testing, we developed labeled datasets and benchmarks to perform automated testing. We use those datasets to run tests whenever updating endpoint or prompt to ensure performance was consistent. Implicit customer feedback was another method for automated testing. For instance, if a customer accepted and published the status update we generated, it's a signal for us that the model performed well. We also use techniques like use an LLM as a judge to compare and rank generated outputs. Of course, we also closely monitored metrics such as number of requests, latency, input-output lengths, and token counts to detect any changes in the behavior. This helped us identify and address any issues promptly. To complement performance evaluation, we also focused on risk management. Our approach included several steps. We began by identifying potential threats specific to each use case. It's important to be specific, providing examples and assessing the potential impact, reputational or financial, of each threat. Additionally, we evaluated the probability of each threat occurring, distinguishing between a theoretical and actually practical risks that can happen. For each identified threat, we defined mitigations. Some mitigations aim to prevent the threat, while others focus on reducing the risk or identifying the threat after it occurred. We also considered the effort required to implement the mitigation, balancing development time, cost, and the impact on the feature latency. If one of the mitigation would be to have additional 5 LLM calls to detect other things, obviously it will affect the cost and latency. After identifying threats and defining mitigations, we prioritize them based on their potential impact, probability, and the effort required for mitigation to be implemented. This helped us to decide which mitigations to implement and which risks to accept given our constraints and available resources. Before we finish, there are a few key takeaways that you can implement and apply in your organization. So as we said, early planning saves time later. Although we needed to move fast, we still took time to align our efforts, define processes, and create design document for each feature. Early planning helped with alignment, especially with involving multiple teams and roles. Second, not every use case requires an LLM. It's crucial to evaluate which use cases generally need LLMs and where other solutions might be more appropriate. Data scientists and ML engineers, applied scientists can help make that determination. Third, start with the simplest approach and iterate. I think it's valid advice for every feature we develop. This principle is essential for fast development. A simple version can be ready quickly, and you can improve while iterating. Fourth, clear, defined roles and responsibilities. You want to leverage the skill set and expertise of each team member and each skill set efficiently. Last, but maybe most importantly, collaboration and teamwork are key. One of our core values at PagerDuty is run together, and it was crucial for developing our features quickly and successfully. Thank you for listening. We will be happy to get any questions.
Hi, a very good presentation by the way. I'm Suchita from BSF and I work with the GenAI enablement team, and our work is very similar to what you showed. The process, just names are different, but it's very similar. And the main problem we are facing now is to as well how to develop it faster and roll it out faster. So I wanted to know in that process, what point is the checkpoint where it takes the longest time?
It will depend on the use case. For some more complex use cases, the feasibility research can take a while until you actually get to the point where you have something that you are confident you can develop. For more simpler use cases, most of the phases are relatively fast, and I would say the iterations to actually be ready for the release may take longer, because with feasibility testing you can quickly see that it's something similar to what you did before, and it actually works pretty well. So it would depend on the use case and the use case complexity. As I was mentioning, some of the use cases require changes to the LLM API. For example, now we're integrating RAG model infrastructure. So this use case takes a while actually for the ML engineering team in their stage to provide this endpoint to support RAG model requests.
And I really like the point you made about the single point of access for LLM, because each and every one who's developing will come and ask for a new provisioned model. So just having a single point of access and providing them the endpoint and API sounds like a really great idea.
Thank you.
Wonderful presentation, though. Thank you.
You did mention RAGs and how you're implementing that within your LLM API service. What about other implementations like fine-tune models, fine-tune versions of your models, or like LLM chaining and things like that? Is that something you're doing?
So, do you want me to address that question? Sure. I think, as Suchita mentioned, there are options to support also self-hosted models. And models that we fine-tune based on our data would be just another example of this self-hosted model. Of course, the training and fine-tuning will happen offline, not before, and then we can just integrate it with the data science LLM API and use it as another model that we are supporting. Currently, for the features we released, we don't fine-tune models or train our own models.
Makes sense. Thank you.
Any questions about the features in PagerDuty, the Gen AI features, the process, or anyone wants to share their experiences?
Yeah, one more question. So it was a nice presentation. Thank you so much. And I was wondering, as part of the use case that you described, is streaming the response from LLM is also a feature or kind of an expected behavior that you would support? If yes, like how would you kind of handle it? Like which piece would handle this streaming response from LLM?
Streaming response?
Yeah, you can.
Yeah, I didn't get your question. Like you're asking about the streaming response?
Yeah, like for the use case that you use LLM for, say you want to fill the incident or the postmortem, for example, would you consider like, streaming the response from LLM so that you don't have to wait for the complete response generation, rather?
So I think it's something we look at for the new endpoint we mentioned with the RAG model, because the generation, while like retrieving the results and generating the output, can take longer. For the current features we released, we don't stream the response. We return the full response.
Okay, thank you.
Great presentation. For the API, are you guys using hosting the API on a custom front end, or using something like Teams or Slack for ease of use for, let's say, internal customers or even external?
The models?
Yes.
So we are using OpenAI, Azure OpenAI. So we are using the APIs to
external
with
providers.
The external APIs. We don't have any internal models as of now. But in future, if needed, we can have like self-hosted models.
And the front end is something like Teams or Slack, or?
So it will depend on the features. So for example, the generative AI assistant, the feature we released in November, it's accessible through Slack. So it's like a chatbot that you can type the question and get the response in Slack. For some of the other features, you have a dedicated UI in the product. So if it's like a runbook generation in the automation part of the PagerDuty product, when you define the runbook jobs, you will have like a button to create it based on the input. Same for log generation, summary AI, automation digest. For status updates, you actually can access from the part in PagerDuty platform where you generate the status updates, but you can also integrate it. We already integrated with AI assistant, so you can type in Slack saying, help me generate a status update, and you will see it in Slack. So there are different interfaces to interact with the features. Eventually, we do want to integrate a lot of our Gen AI capabilities and other capabilities into Slack or MS Teams or multiple interfaces for our customers to get everything together in one point.
Thank you.
Any more questions? Anybody? No? Okay, well, thank you so much, Irena and Suchita.